Okay, so on this lecture, I just wanted to go over our third quiz. So for quiz 3, I'll read you the question right here just in case you don't remember it. But it says, a certain particle has a half-life of 10 to the minus 7 seconds. That's the half-life. How far on average does it go before decaying if its speed is 0.8 c? So it's moving at 0.8 c. How far does it go, on average, does it go before it decays? And remember that when you're measuring the half-life, that's when the particle is at rest. This particle is not at rest. So this one's living longer than the half-life. We know that this one is going to live longer by T naught all over the square root of 1 minus v squared over c squared. Well, if we plug in right here, it's going to be T naught all over the square root 1 minus 0.8 squared is 0.64. 1 minus 0.64, the c squares drop out. 1 minus 0.64 is 0.36. Take the square root of that, and it's 0.6. So this is T naught all over 0.6. I like 0.8 because it's easy to go through the math right here. We want to know is how far does it go? Well, we know that the velocity that it travels is the distance over the time, or the distance equals the velocity times the time. Velocity times the time. And the velocity they gave it, and the time we know, so we can just plug it in. The velocity is 0.8 c, and the time was T naught over 0.6. T naught, which is this, 10 to the minus 7, all over 0.6. Well, we might as well plug in what c is. Instead of making that 0.8 over 0.6, I could just make it 8.6. 8.6, just move the decimal place, times the c, which is 3 times 10 to the 8th meters per second, times 10 to the minus 7 seconds. So the seconds would drop out, and you're just left with meters. Well, this and this just gives you 10. This is 24. 24 divided by 6 is 4. 4 times 10 is 40. So this answer was 40 meters. So it would go about 40 meters before it decayed. Okay, didn't even need a calculator for that one. Okay, number 2 was an electron. We know what the mass mc squared of an electron is. It's 0.511, but we're going to just go 0.5 MeV. It's close enough. It has a kinetic energy of 1 MeV. And they want to know what is the speed. What is the speed? U equals what? Right there. Well, what are we going to do? I could have just, they gave me the kinetic energy. We could either use this right here and just use that equation. So the kinetic, which is 1 MeV, equals mc squared, which we know is 0.5 MeV, all over the square root 1 minus v squared over c squared minus mc squared minus 0.5 MeV. Okay, all the MeVs drop out. We can pull out the 0.5 right here. And so, and we can bring it down below. So we got 1 over 0.5 equals 1 over the square root of 1 minus v squared over c squared minus 1. Well, this is just 2. bringing that over there, that's just 3. So we got 3 equals 1 over the square root 1 minus v squared over c squared. Square both sides, 9 equals 1 all over 1 minus v squared over c squared. Flip both sides, 1/9 equals 1 minus v squared over c squared. Swap these two. V squared over c squared equals 1 minus 1/9, which is 8/9. Or v is equal to the square root, that's 2 square root of 2 all over 3c. And since I have it in a decimal form, that's 0.94 c, 0.94 c. Okay, so that was question number 2. Question number 3 was, they said the frequency of red light, frequency of red, is 4 times 10 to the 14 hertz. Okay, and now it says if an observer ran at c over 2 toward the red light, what would he measure the frequency to be? Well, now he's running towards it, so the frequency is going to be higher, not the one we, so he's, remember when we derived it, he was running away from it right here, but this would be f, this frequency of the red right here, and then we're going to have the square root, this is going to be 1 plus v over c all over 1 minus v over c. It has to be greater because he's running towards you. Okay, and we said he was running towards you at c over 2. So v is equal to c over 2. Well, so that means the frequency you measure is this frequency, 4 times 10 to the 14th hertz, times the square root. Since this is c over 2, this just becomes 1 plus a half all over 1 minus a half. 1 plus a half all over 1 minus a half. This is just 4 times 10 to the 14 hertz, square root, this is 3 halves divided by 1 half, the halves drop out, it's the square root of 3 times bigger than this. And 4 times the square root of 3 is 6.9 times 10 to the 14 hertz. So there was the answer right there. That's the frequency you're going to, that's probably up, that could be up near green, right there. If I would have asked for wavelength, I didn't, but there's a relationship. We know that the frequency times the wavelength is the speed of light. So if we wanted to convert it into wavelength, you could just say it's the speed of light divided by this number. Okay, number 4, it says, what is the kinetic energy and MeV of an electron moving at 0.8 c? Well, we have an electron moving at 0.8 c, and we want to find the kinetic energy. Okay, well, I guess we could have gone back here and plugged it into, did they give me the speed? Yes, they gave me the speed, so we'll just plug it into this right here. The kinetic energy is equal to, I'll write the equation down first, mc squared over the square root of 1 minus u squared over c squared minus mc squared. We want to get this right here, and then we're given everything else. So this is a half, 0.5, maybe we'll just call it 0.5. 0.5 MeV all over, remember we already did this 0.8 already before. I think we did it way back here. Remember this was 0.8 C, and remember the whole square root term just becomes 0.6. Right? Yeah, that's why I like to use it. So this whole thing is just 0.6 right there, minus 0.5. So this becomes, well, this is 5/6 minus 0.5 right here. So this is 5/6 minus 1/2, really, you could say. So if I put this And get a common denominator right here. This is 2/6, which is 1/3, which is like 0.33 MeV. Okay. Number 5. Two particles of equal mass and equal speed. So you got an M and a U are heading towards each other on a head-on collision. So this is M, this is U. The two particles stick together and form a total mass of 3m. What's the speed? What are the u's in this problem? Well, we know from momentum that this is not moving afterwards because they have equal momentums coming in. So we know it's at rest. So if we look at the energy of this, which is the total energy, remember our total energy, we can get it from right, well, there's our total energy. Remember, it's just our total energy right there. It's mc squared all over. So this one is mc squared all over the square root of 1 minus u squared over c squared, plus that energy, but that has the same energy because it has the same mass, same speed, so I can double it. And then afterwards, it's no moving, so it's all rest energy, which should be mc squared, 3m c squared. Okay, we can get rid of the mc squares. Bring that down below. We got 1 over the square root, 1 minus u squared over c squared equals 3/2. Square both sides, 1 all over 1 minus u squared over c squared equals 9/4. Flip both sides, 1 minus u squared over c squared equals 4/9. Swap these two. 1 minus 4/9 is 5/9 equals u squared over c squared, or u is equal to the square root of 5 over 3c. And that is about 0.75 c. Okay, and then the last question here was a particle of mass m and kinetic energy 2mc squared. So here we got a particle of mass m, and the kinetic was 2mc squared. Collides with a particle at rest. So this is of equal mass, but this has no kinetic. The two particles stick together right here. But they won't be at rest because this one was moving and he ran into something at rest, and together they're moving right here. But it forms 3m. This is a 3m mass, but it is going to be moving right there. They didn't ask for that. No, that's what they asked for. What is the speed? This is what they want. They want that u right there. Well, if we look at it, first of all, we can see that if we looked at the momentum equation, we know that this momentum plus 0 equals this momentum, which really means this momentum equals that momentum. The p of this guy is the same as the p of that one. And since they're both the same p, I might as well just call them all p. I don't need a subscript anymore. Now let's look at the energy. The energy before the collision, you had, this one had rest energy, mc squared, plus it had some kinetic, plus 2mc squared, plus that had some rest energy, mc squared, without any kinetic. And then afterwards, the energy of this right here is the total energy. I can just use the E. Remember, E is just mc squared all over the square root of 1 minus u squared over c squared. But in this case, it's 3m c squared all over the square root of 1 minus u squared over c squared. And they gave us everything except for u. They just want to find u. I could cancel all the MC squares, but here I might as well combine them first. This is 4MC squared. And now I'll cancel them. Then we'll bring down the 3. So you got 4/3 is equal to 1 over the square root of 1 minus u squared over c squared. Square them and flip them. I'll do it in one step. So this is 9/16 equals 1 minus u squared over c squared. Flip those two. So u squared over c squared equals 1 minus 9/16, which is 7/16, or u equals the square root of 7 over 4c, which is 0.66 c. So hopefully this quiz wasn't that bad. It shouldn't take you, I gave you an hour. I think this was plenty enough time to do it in. Okay, so now we can go on to the next big problem in modern physics.